This is section 4.9, part B. We're going to look now at multiplying radicals. Unlike adding and subtracting, where we had to have like radicals, multiplication has much less stringent rules. We can multiply any radicals as long as they have the same index. Don't have to have like radicands, just the same index. Always simplify after you multiply by doing our usual techniques for simplifying radicals. One other thing to keep in mind, outside the radical numbers multiply other numbers outside, inside numbers multiply inside numbers, and also watch out for our common strategies, distributive laws, FOIL process, those kinds of things. In number 1, I'll start out by multiplying the numbers outside the radical, negative 18, and then also multiplying inside the radical, 48x squared. There's my product, but it's not in simplest form yet. I'll keep the negative 18 as a multiplier, and then I'm going to break down the radical. I need a perfect square that's going to go into 48. I think the biggest one I can get is 16. That's 16 times 3. X squared is already going to come out evenly, so I'm going to keep that up here with the 16. So I have negative 18 multiplied by just 4x to the first times the square root of 3. Negative 18 times 4 would be negative 72x times the square root of 3. And there's the product simplified. All right, second one. A lot going on there, but I'm going to notice this 3 is outside this first set of parentheses, so I probably need to distribute that 3. And by the same token, that 5 is outside the second set. So I'm going to need to distribute the 5 as well. Let's start with that. I'll have 3 times the square root of 2x. And 3 can multiply negative 4. They're both outside numbers. So negative 12 times the cubed root of 2x. Distributing the 5. 5 times 3, so plus 15 times the cubed root of 2x. And 5 times negative 6 will make that a minus 30 times the square root of 2x. None of these radicals can be broken down in any useful way, so I can't simplify them. All I can do is combine like radicals at this point. So I'm going to notice that like radicals would be the square roots have the same index. So combine coefficients. 3 minus 30 would be negative 27, square root 2x. And then the cube roots of 2x also are like radicals. So I can combine those by combining the coefficients. Negative 12 plus 15 plus 3 times the cube root of 2x. Can't combine any further since the different indices mean I now have unlike radicals. All right, take a look at number 3. Does this look a lot like two binomials being multiplied together? It is. This is something we can do with our FOIL process. FOIL, first, outer, inner, last. Okay. First, I would have a 2 on the outside, and then under the radical, a times a is a squared. The outers, 2 times negative 3 is negative 6, and under the radical, a times b. The inners plus outside I really just have 1s, so I still have a 1. And b times a, which is the same as a times b, so I'm just going to write it as the square root of ab. Lasts, minus 1 times negative 3 is negative 3. And under my square root, b times b is b squared. Couple things I can do to simplify. First of all, those 2 square roots come out evenly. So I can definitely just call that one 2a and that one minus 3b. And then notice that these 2 terms have like radicals. So it's okay to combine them. This is really a plus 1 here. Negative 6 plus 1 would be negative 5 times the square root of AB. That got a little spread out, so let me just kind of bring it all together for my final answer. Number 4. Number 4 is actually a lot like number 3. Be careful to avoid the common mistake. You cannot just square each term separately. Squaring something means multiplying by itself. So this really is 4 square root 3w minus 5 times another 4 square root 3w minus 5. Okay. Once again, I'm going to do the first, outer, inner, last. So on the firsts, 4 times 4 is 16. And under my square root, I would have 9w squared. On the outers, negative 20 with a square root of 3w. And for the inners, the exact same thing. Negative 20 square root 3w. And then in my lasts, negative 5 times negative 5 is a positive 25. All right, so let's see what we can do to simplify. The first term, 16, is really multiplied by just 3w. That radical came out evenly. I've got some like radicals in the middle here. So if I just add the coefficients, negative 20 and negative 20, I'd have negative 40 times the square root of 3w plus that 25 on the end. And I'm just about there. 16 times 3w would be 48w. And the rest of it's just going to stay the same. No more like terms, nothing more to combine. All right, we started out by saying that in order to multiply radicals, they had to have the same index. It turns out that in some special situations, we can actually handle radicals with different indices by converting the radical into a fractional exponent. So look at these last 2 examples of multiplication, 5 and 6 down here. These have a different index, 4 and a 6, so I can't just multiply the x times x and call it an x squared under there. What I can do, though, is change this to x to the 1/4 power and change that to x to the 1/6 power. Remember that when you multiply, you actually add exponents. So this is the x to the 1/4 plus 1/6 power, which if you can do that in your head, more power to you. No pun intended. But otherwise, the calculator will do it for us. We'll just change our answer back to a fraction. And we have x to the 5/12 power. There's really nothing wrong with writing something as x to the 5/12, but typically we like to give the answer using the same kind of notation as the problem started with. And since I started with radicals, Let's rewrite my final answer again with a radical. I would have the 5th power and the 12th root. All right, I can do something similar over here. This is a binomial, and I want to square it. So for starters, I know that I need to multiply it by itself. I am going to run into trouble with the fact that I have two different indices, a 5th root here and a square root there. So before I even start to do the FOIL, I'm going to rewrite this with fractional exponents. That will become an n to the 1/5. That one will become an n to the 1/2. And the same thing in the second factor. All right, keep in mind, again, when we multiply, we add exponents. So when I do the firsts, 2 times 2 is 4, and I'm going to add the powers on the ends. 1/5 plus 1/5 is 2/5. The outers, I'll get a +2, and again, when I multiply the ends, I'm going to add the exponents. 1/5 plus 1/2 is 7/10. With the inners, again, I'm going to get a +2, and I've got the same 1/2 plus 1/5. So I'll get 7/10 again. Oops, forgot my n. And the lasts, n to the 1/2 times n to the 1/2. 1/2 plus 1/2 is just n to the first. All right, so let's see what we actually have here. 4n to the 2/5. These are like terms. Both are n to the 7/10. So I'll add the coefficients, 2 plus 2, and I have 4n to the 7/10. Plus n to the first, which is just n. And again, there's nothing really wrong with that answer, but since it started with radicals, let me just convert my final answer into radicals as well. That would be the 2nd power, the 5th root. That one will be the 7th power, the 10th root, and I still have the plus n. All right, that brings us to the end of Part B.